In the diagram, O is the center of circle ABCD, and angle BCD is equal to 107 degrees. Calculate the value of angle BAD. And so here we want to figure out what is the value of angle BAD. And so here angle, so BAD. So what they actually want us to figure out is what is the size of this angle, angle A. And so in order to do this, we're going to use this theorem. And the theorem says that the opposite angles in a cyclic quadrilateral total 180 degrees, which means that if we have this angle, which is X, and the opposite angle in this cyclic quadrilateral is this one, that means that if we know that this is X, then this one has to be 180 minus X, because when you add these two, you should get 180 degrees. So if you know what is the size of this angle, the size of the next one that's opposite to it is going to be 180 degrees minus X. Okay, so here we have a cyclic quadrilateral, and we know that because it's a quadrilateral. It has 4 sides, and the vertices of this quadrilateral is on the circumference of the circle. So we have a cyclic quadrilateral. We know what 107 is. We know that's the size of this angle, but the theorem says that the angle that is opposite 107, the angle that's opposite 107 must be, when we take this angle and this angle, they have to add up to 180 degrees. And so if we know that this is 107, and we know that this angle right here and 107 degrees must add up to be 180 degrees, then that means that angle A is going to be 180 minus 107. 180 degrees minus 107 is 73. So angle A here is 73 degrees, and that's because 73 plus 107 is 180, okay? And so that's the answer here, 73 degrees. Okay, next we need to figure out what is the value of angle BOD. What is the value of angle BOD? Now, what is BOD? Well, BOD is going to be this particular angle right here, BOD. That's this angle. What is the size of this angle? Well, we could use this theorem, and the theorem says that the angle at the center is twice the angle at the circumference, which means that if the angle at the circumference is x, then the angle at the center is 2x. And so since we know that the angle at the circumference is 73 degrees, then the angle at the center is going to be 2 times 73 degrees, and 2 times 73 degrees is equal to 146 degrees, and that's the answer to this question. Next, we have to determine what is angle OBD. Angle OBD. Now, OBD, that's what we need to figure out. What is the size of angle OBD? Now, notice that we have that we're actually referring to this angle. This is angle B. That's what we're trying to figure out the size of. And so angle OBD, they actually want us to figure out what is the size of angle B, because that's the one in the middle. And this angle, right? This angle is actually one of the angles that are inside of this particular triangle, okay? Now, notice that we have OD, right? This side, and OD is actually a chord in this circle that starts at the center and ends at the circumference, right, of the circle. So it runs from the center all the way to the circumference. And so it's not a chord, it's a line segment, sorry. It's not a chord. So if you have a line segment that runs from the center of the circle to the circumference, then that line segment would be the radius. And again, we have a line segment that runs from the center of the circle all the way to the circumference of the circle. And so that would also be the radius. Now, so both of these are the radius. So that means that this side and this side must be equal. So those two sides are equal. So this side, right, is the radius, and this side is also the radius. So both of them are equal in length. So that means that the two sides of our triangle are equal. And if we have two sides of the triangle that are equal, then we're dealing with an isosceles triangle. And if two sides, and in an isosceles triangle, two sides and two angles are equal. So if we have two sides are equal, in this case, these two sides are equal, then that means that not only are the two sides are equal, but the two angles are equal as well. So that means that if this is A, that means that this must also be A as well. Okay, so the two angles are equal as well. Now, what do we know about the sum of the angles in a triangle? Well, angles in a triangle add up to 180 degrees. So what we're gonna do is we're gonna take 146 and subtract it from 180. And when we subtract that, we get 34. But then we're gonna divide it by 2 because we have to split 34. We have to share it equally into two parts, all right? So we have to split 34 equally. We have to share it equally among 2, right? And so that means that we have 34 divided by 2, and 34 divided by 2 is 17. So what does that mean? Well, that means that this is 17. This angle here is 17. So, and then also mean that this angle here is 17, okay? And so what does that mean? That means that angle OBD is equal to 17 degrees. 17 degrees is our answer. Okay, now the next part of this question says that DT is the tangent to the circle at D. So DT is the tangent to the circle at D. Write down the value of angle ODT. Write down the value of angle ODT and give a reason for your answer. And so we have this theorem, which is the tangent of a circle. And it says that the angle between a tangent and the radius is 90 degrees. So we have a radius and we have the tangent. The angle formed between the radius and the tangent is 90 degrees. And so we have the radius, OD, because it's a line segment that runs from the center of the circle to the circumference. So this is the radius. And we have the tangent, and this is the tangent line right there. And so the angle formed between the radius and the tangent line is going to be 90 degrees. So ODT is equal to 90 degrees. And the reason is because the angle formed between a tangent and the radius is 90 degrees. And that's the answer to this question.